Hello, my name is Rob Reynolds. Welcome to Math 073. Today we're in Chapter 5, looking at Section 3, and we're going to explore how to divide a polynomial, being monomials and polynomials with many terms. And we're going to look at two different methods for this. We're going to look at long division, dividing by polynomials, and synthetic division. But remember, for synthetic division, in order for this to work, this needs to be in the form of x minus a, and I'll talk to you that in a moment. So first of all, if we divide by a monomial, I want to remind you that we rewrite the base and subtract the exponents for variables. And there's a couple examples of how to do that. So this is a 4. If there is no exponential number on the variable, then remember there's a 1 there, so that's how they got this 4 minus 1 is this 3. So an example of that would be this problem, and literally what's happening here is you're just going to divide each term by the monomial, one term. So I'm going to rewrite this so that you can see that each term is being divided by 2ab. So here we go. 6 divided by 2 is 3. A squared, because I had 3 minus 1. B minus 5. The b's cancel. I'm left with 1a up top. Plus, now all of this cancels, the a and the b, and I would just leave this 5 halves. I wouldn't go to 2.5. But you could, certainly, and the author gets the same answer. So dividing by a monomial is fairly simple. You just divide each term by the monomial. So if you have more than one term, I wanted to remind you that you've done this before in elementary school. If you have 24 going into 85,582, the process is you come up with a number. 25 goes into just 85 3 times, and you multiply 3 times the 24, get a 72, and remember that you were going to subtract. And it's this subtraction that gets difficult, and I'll try to come up with a way to remind you to do that. So we subtract, get 12, and then bring down the next term and repeat the process. 24 goes into 125 5 times. So long division, we're going to set it up. X minus 3 goes into 3x squared minus 4x minus 15. And again, we're just going to look at the first term. X going into 3x squared. I know there's more to this, but really that's a good trick of how to do this. We think about how many times does 2 go into the 8. If you don't know how many times 24 goes into 85, we can just say, well, how many times does 2 go into 8? Well, it goes 4 times, and 4 doesn't work, but something close to it, like a 3 did. So we'll do the same thing. X times what value gives me 3x squared, so it's really x times what goes in the box to give you 3x squared. And if you wanted to, we could just divide through by x to solve for the box. Well, the box is going to be an x term, and it goes up here. And of course, that's just going to be 3x. And notice I'm lining up the x terms on top of the x terms. And that's something similar too. Where you line these up at becomes very important. So that the 4 is on the 1s. And so continuing, we're going to start multiplying. 3x times the x gives me 3x squared. 3x times the negative 3 is negative 9x. Now remember, we're going to subtract. And my recommendation is instead of subtracting, I would add the opposite. So I'd go through and change all the signs and add. Usually students are better adders than subtractors. So 5x minus 15, bringing down the next term, and repeat the process. X goes into 5x 5 times. Multiply. 5x minus 15. Subtract, and this comes out even. So the final solution is 3x plus 5. And here's how the author chose, but the quotient is 3x plus 5. Let's repeat this process with x plus 4 going into 5x squared plus 2x minus 14. So again, x goes into 5x squared 5x times. Multiply. 5x times x is 5x squared plus 20x. Here comes the difficult part. subtracting, meaning add the opposite. I would change all the signs. So this really says 2 take away 20, so it's negative 18x, and bring down the next term. And repeat the process. X goes into negative 18, negative 18 times, and negative 18x minus 72. If we subtract and add the opposite, I'll get a positive 58, which it didn't come out even, so this is called the remainder, and I'll say plus 58 divided by the divisor x plus 4. So final solution. I had to check this with Wolfram Alpha because the author made a mistake here. So here's Wolfram Alpha showing you how to work this out with long division. The author, for some reason, has x plus 4 here, but actually chose to divide by x minus 4, which is incorrect. So the author is going to get a little bit different remainder and a little bit different answer. This 22 we didn't get. So let's not follow the author's worked out solution. Even with their check, by multiplying it back together, they used an x minus 4, but if you remember, the original problem was an x plus 4. So a little bit confusing how the author did this. So here we go. Dividing by 4x plus 1. We need a placeholder here because this is a cubed, and after a cubed we have no x squared term, so I would recommend that you write a 0x squared for a placeholder, minus 6x plus 12, and that way I've got a x cubed, x squared, x term, and a constant. And that placeholder becomes important, you'll see here in just a moment. 4x goes into 32, 8x squared times, and I'm going to put that above my 0x squared term and multiply. 32x cubed, if I multiply by 1, I just get an 8x squared. I'm going to subtract and add the opposite and bring down a negative 8x squared. And the next term is negative 6x. Repeating the process, 4x goes into negative 8x squared, negative 2x times, and we'll multiply. Negative 8x squared, remember this negative 2 gets multiplied by this 1 next. Continuing to distribute gives me a negative 2x. Here's the tricky part. We're going to subtract and add the opposite by changing all of the signs. Adding straight down, negative 6x plus 2 is negative 4x plus 12. 4x goes into negative 4x, negative 1 times. We'll multiply. Negative 4x minus 1. And last, add the opposite for a remainder of 13. So I'll write this plus 13 over my divisor, 4x plus 1. Let's see if the author agrees with this time. And I think he does. All right, another method of division is called synthetic division. The reason why synthetic division works is because we can just get rid of the variable x and synthetically divide. The numbers that we're interested in is this 2, negative 2, and negative 4, and we get the same thing. Remember, synthetic division really only works with this x minus a term, so I need, like, here's my x and minus a. If it was something like 2x minus 3 and I was dividing by that, I would not choose synthetic, I would choose long division. So synthetic division says I'm going to set this x minus 4 equal to 0 and find the root. So the root of this is 4. So you really kind of just change the sign here. The factor is x minus 4, but this is called the root. And that's where the function actually crosses. It's an x-intercept. It's called a root, or 0. So we're going to divide by the root of 4. Notice I'm changing that negative 4 to a positive 4. And I'm going to just put down the coefficients here. 2, negative 1, negative 43, and 60. So for synthetic division, we're going to drop the first term and then multiply. 4 times 2 is 8. We'll add straight down. 8 and negative 1 is 7. Multiply for 28. We'll add for negative 15. We'll multiply 4 times 15. Put the answer here, negative 60. And if it comes out to be 0, then it divided evenly. There's no remainder. So if I divide through by x minus 4, x cubed divided by x is an x squared, and that's what this term here is. So I'm going to rewrite this as 2x squared plus 7x minus 15, and there's no remainder. So that's final answer. Here's how the book is explaining it. And they get the same solution that we did. Let's try again. Again, the divisor is being divided by x minus 1. So if I set y minus 1 equal to 0, I'm going to synthetically divide by a 1. So I'll say 1 is the root. So if I synthetically divide by a 1 coming from this factor, y minus 1. Now be careful, I need some placeholders here. This actually says y cubed plus 0y squared plus 0y minus 1. And I'm just going to pick the coefficients. 1, 0, 0, negative 1. Bringing down the first term is a 1. Multiplying. 1 times 1 is 1. Adding. Multiplying. Adding. Multiplying. And then lastly adding. Again, that came out evenly. If this was a y cubed, I just drop it by 1. Because y cubed divided by y is y squared. So I know this first term has to be a y squared term plus y plus 1. And again, it came out evenly because my remainder was 0. Here's how the author worked it and their solution. Let's try a little bit harder one. If the factor is x plus 5, I'm going to synthetically divide by a negative 5. The coefficients here are 1, negative 9, negative 7, and be careful, there's no x term, so I'll create a 0 for a placeholder. And last, I'll have the constant of 10. Bring down the first term, multiply negative 5 times 1, add, multiply 5 times 14 is 70, adding straight down is 63 times negative 5 is negative 315, adding negative 315, and multiplying 315 times 5 is a big number, 1575, it's positive. I'll add 1585 is the remainder. I started out with an x to the 4th, so I'll decrease it by 1 because I'm dividing by x to the 1st, and so that means the leading coefficient is an x cubed term. And then I'll just walk down x cubed, x squared, x, this is my constant, and then the 1585 must be the remainder, and I divided through by x, x plus 5. Final answer, and author agrees. So remember, we're not dividing through by the root, negative 5, we're really dividing by the factor, x plus 5. And I'll talk more about the difference between factors and roots in a later lesson and how they relate to the graph. I hope this video was helpful. Email me with your questions. Thank you.